So you can check the 5 volt in the pin number 1 or in this capacitor. As you can see here, we have plus. Okay, because the plus of this capacitor is connected directly to the pin number 1. As you can see, this is the USB connectors. So we have two connectors in this motherboard, and here we have the USB connector circuit. Okay, so here we have a chemical capacitor or polarized capacitor. As you can see, we have here a ceramic capacitor, an IC, a fuse, and an inductor. For this connector also we have a chemical capacitor, an IC, a fuse, and an inductor. Okay, this component are the component that you have to check if you have a failed USB connector. Okay, so here, as you can see in the schematic, this is the USB connector circuit diagram. As you can see here, we have USB connector 1. Okay, so we have here 4 pins. As you can see, always the pin number 1 is for VCC. Okay, as you can see here in the motherboard, we have here 1, means here this is the pin number 1 over here. Okay, in other motherboard you can find a mark like this, a triangle, means this is pin number 1. Okay, here we have pin number 1, 2, 3, and 4. Always the pin number 4 is connected to the ground, exactly as you can see here. Always the pin number 4 is connected to the ground. Okay, and pin number 1 is connected to the VCC, as you can see. So you can check the 5 volt in the pin number 1 or in this capacitor. As you can see here, we have plus. Okay, because the plus of this capacitor is connected directly to the pin number 1, as you can see. Okay, so let's go back to the schematic. As you can see, so we have the USB connector. Okay, and here, as you can see, we have the IC. This IC is the responsible for generating USB VCC. As you can see, this IC take a 5 volt, a normal 5 volt, and generate a USB VCC that is equal to 5 volt. This 5 volt will be applied to a chemical capacitor or to a polarized capacitor with 6.3 volt, as you can see, and we will get a filtered voltage 5 volt. Okay, so that's why if you want to check the USB connector, you can check the voltage in the pin number 1 or either in the plus of the chemical capacitor. Here, for example, you can check 5 volt here in the pin number 1 or here in the plus of this capacitor. The same for this, you can check 5 volt here or here. Okay, then we have here, as you can see, D minus and D plus. This is the data, as you can see here. So this signal pass through an inductor, as you can see, and comes from the ICH. Here the 16 is where the ICH exists. Okay, so if you have problem in the USB connector, what you should check? First, you should check here these terminals, these 4 terminals inside the USB connector, and check whether this terminals is in good shape or not. If you find this terminal are damaged, you should replace the whole connector. Also, you should check, as you can see here, this pins here and the soldering. If the soldering is bad, you should put another good soldering. Okay, and then go ahead and check the fuse. As you can see here, we have the fuse. Here also we have the fuse for this connector. Check the capacitor, whether the capacitor is good or not. You can use the multimeter. You can just put the selector of the multimeter in the buzzer option and then check this 2 capacitors. If you get a continuity or if you hear a buzzer, then these capacitors are bad. So you can check the fuse and also the inductor. The inductor should give to you a buzzer or a continuity, because the inductor is exactly like a fuse. And then here we have some PF capacitors that you can check using the same principle, working principle as the chemical capacitor. Okay, so to check the USB connector, you should check first this connector, the terminals inside the connector, then check the solder here. As you see, the soldering, is it good or not? Then check the fuse. As you can see, the fuse for each port or each connector, then the chemical capacitor, the inductors, then the IC. But to check the IC, you can just check this PF capacitor. If you find that this PF capacitor is shorted to the ground, means the IC is bad. Okay, the same working principle. For example, for this port in this motherboard, the first thing to check is the connector, the terminals inside the connector, then check the soldering here, as you can see. Then you can check the inductors. As you can see, we have here inductors. You should get a buzzer by checking this inductor using the multimeter. Then check the filtering capacitor. Okay, and of course here for this USB connector we have this IC U13. You can check it by checking the PF capacitor near to the IC. Okay, I want to add that sometimes you can find in the USB connector 5 volt in the pin number 1, but the USB connector still not working. Why? Maybe these two signals are missing. As you can see, USB data minus and USB data plus maybe are missing. If these two signals are missing, so maybe you have problem in the inductor. You should check the inductor. If the inductor is opened or cutted, this signal will be missed. But if you check these inductors and you find the inductors are good, then the problem maybe is in the ICH or in the circuit bridge. Maybe the USB connector inside the ICH is failed. Okay? But to confirm and to be sure, you should go and check other USB connector. For example, if you have in the motherboard 2 or 3 USB connectors, if you find all USB connectors stop working, even if the 5 volt exists, means the ICH or the circuit bridge is failed. Okay? But if you find just one USB connector are bad, but other are worked correctly, means you have problem maybe in this USB connector itself. Okay, or in one inductor here. Okay, so for this motherboard, as you can see, we have the USB connector, we have here the chemical capacitor. As you can see here, we have the chemical capacitor, but here we don't have anything. Let's see the other side. So as you can see, this is the USB connector. So here, as you can see, we have the IC. Yeah, this is the IC U60, and this is the resistor near to this. This is a network resistor. Okay, and here, as you can see, okay, as you can see, this is for data. Okay, as you see, we have here this bus. This is a tin or a tin bus, because the data is always about 1.2 volt to 3.3 volt. And of course, here we have the other pins. So we have here the 5 volt, and here we have the ground. We will check all this. So remember with me the schematic. Okay, we have here the USB connector. Okay, so the USB connector is the pin number 1 is connected to the chemical capacitor, the plus of chemical capacitor. Okay, and to ceramic capacitor. Okay, and here of course the chemical capacitor is connected to the V out of the IC that is responsible of generating USB VCCA. Okay, so for us, we will check in the motherboard whether the chemical capacitor is connected to pin number 1. We will check also these two inductors, as you can see here, and we will check also the IC. Please remember the schematic. Okay, remember the schematic. Pin number 1 is connected to the chemical capacitor and to the V out of the IC. Pin number 2 is connected to one inductor. Pin number 2 also connected to other inductor, and pin number 4 also connected to the ground. Okay, now let's go to the motherboard and use the multimeter to check all components. So as we have seen before, here we have the one here, means this should be 5 volt and this should be ground. So let's check whether this is ground or not. So first we should put the multimeter to the buzzer option, as you can see here, and then press the power button. Okay, so let's check the continuity. The continuity is set correctly. So for this USB connector, here this is for 5 volt. Why? Because here we have 1. Means this should not be connected to the ground, as you can see. Okay, not connected to the ground, but this should be connected to the ground, as you can see. Okay, the same also for this. This should be connected to the ground, but this should not be connected to the ground because this is the 5 volt pin, and these two also should not be connected to the ground. If these two pins that are for data is connected or are connected to the ground, means the ICH is shorted. Okay, so 5 volt should need to be connected to the ground. These two pin also for data should not be connected to the ground. If you find that one of these pin or both are connected to the ground, means the ICH is shorted. Here we have the ICH. This is the CPU. Okay, here we have the GMCH or the North Bridge. This is the graphic card, and over here we have the ICH. If you find that these two here or these two here are connected or shorted to the ground, means automatically the ICH is shorted to the ground. Okay, so now let's see the other side of these connectors. So as you can see here in the other side, so we have this chemical capacitor, we have the IC, we have the fuse resistor, we have this PF capacitor, we have the inductor. This component are for this USB connector. So if you focus here, as you can see, you will see here we have 1. As you can see, we have here 1 here. Means this pin here is the pin number 1, pin number 2, 3 and 4. So this means 5 volt. So because this pin, as you can see here, is pin number 1, because we have here 1, it should be connected to what? To the plus of the chemical capacitor. The plus of the chemical capacitor is here, as you see. So let's check. As you can see, so the pin number 1 is connected to the plus of chemical capacitor, exactly as we have seen in the circuit diagram. Okay, and of course the plus of chemical capacitor should be connected to the output of this IC. And the second thing to check is the fuse. Let's check whether the fuse is good or not. So the fuse is good. If you find a buzzer, or if you hear a buzzer, or you get a low resistance in the multimeter, means the fuse is good. So this fuse is good. Let's check also the chemical capacitor. the chemical capacitor is good. If you hear a buzzer, testing the chemical capacitor means shorted to the ground. So the chemical capacitor is good. Here we have the IC. So let's check this PF capacitor. The PF capacitor is good, means the IC also is good. Okay, so for the fuse should get a buzzer. Good, so the fuse also is good. So let's check this chemical capacitor. This chemical capacitor also is good. Now here, as you can see, here we have 5 volt, here we have D minus and D plus, and here we have the ground. So let's check first this pin, the 4th pin, as you can see, to the ground. We should get a continuity or here a buzzer, as you can see. Okay, and if we check these 2 pins, as you can see here, these 2 in the center, in the middle, these 2 pins should be connected to the inductor. So let's check this one. As you can see, connected to the first inductor. So let's check the second one to the inductor. So here we have the first inductor, here we have the second. So let's check, as you can see. Okay, and of course the 4th one is connected to the ground. So let's check the second connector, the same principle. Here we have the first connector. So this first connector should be connected to the chemical capacitor, as you can see. Let's check the fuse. The fuse is good. We have IC. Let's check this PF capacitor. So no buzzer means the PF capacitor is not shorted, means the IC is good. Because always, how can we test the ICs? To test the IC, you should just any IC. Okay? To test any IC, you should just check the PF capacitor around the IC. If you find a bad PF capacitor or ceramic capacitor, if you find, for example, a buzzer, when you check the capacitor like this, means the IC is shorted to the ground. Okay, always you should check for every IC, always you should check the PF capacitor or ceramic capacitor around it. For example, for this IC, you should just check this PF or ceramic capacitor. If you find a shorted capacitor, means the IC is bad. So for this IC, for the USB connector, as you see, we check the ceramic capacitor. The ceramic capacitor is good, means the IC also is good. Okay, and of course for the other pins, as you see, the data minus and data plus will be connected to this inductor. Okay, so as you can see here, for this motherboard, as you can see, it contains just one IC and one chemical capacitor for both USB connector. So as you can see here, we have this dot here. As you can see, we have dot here and we have another dot here. It means the first pin for these connectors are here. Okay, so this is the first pin, and over here we have the first pin here. So let's check the first pin with the chemical capacitor. So let's check. I will put one probe here in the first pin and check with the chemical capacitor. As you can see, we have continuity. So let's check also between the chemical capacitor and the first pin of this connector. Let's check. Normally we should get a buzzer, a continuity, because here we have just one chemical capacitor. So let's check, as you can see. Okay, so the first pin here and the first pin here are connected together, as you can see. So let's check this and this, as you can see, connected together, because here we have 5 volt and here we have 5 volt. Of course, here the chemical capacitor should be connected here to one pin here. The output, as you can see, is connected to this pin, to the output of this IC. Okay, so let's check another motherboard. So here, as you can see, this motherboard, we have a chemical capacitor in this shape. We have here plus. Here we have this mark, this triangle means this is pin number 1, 2, 3, and 4. So let's check the pin number 1 with the plus of the chemical capacitor. So let's check. So here we have pin number 1 here. Let's put one probe here of the multimeter and put the other probe here into plus of chemical capacitor, as you can see. Okay, do you hear a buzzer? Means this is connected to this. Of course, if you focus here, you will find here a bus, as you see. Okay, and this should be connected to what? To the ground, because this is the 4th pin. So let's check, as you can see. And these two are data pins. Okay, these two should be connected to this inductor, as you can see here. So these two pins are for data plus and data minus. Here we have two inductors, as you can see. Okay, here we have L7, two inductors. So as we have seen in the schematic, these two pins should be connected to these two inductors. So let's see again in the schematic. So as you can see here, we have D minus, D plus are connected directly to these inductors, as you can see. So let's check between these two terminals. Let's check these terminals first. So here we have 5 volt, here we have D minus. Let's check this with this, for example, as you can see. So let's check also this with this, as you can see. Okay, so the first pin means the VCC pin is connected to plus of the chemical capacitor, and the second pin means D minus is connected to this inductor, okay, or to this fuse resistor. Okay, yeah, this is a fuse resistor, as you can see. This is a fuse resistor. Okay, do you hear a buzzer? This is a fuse resistor. And the third pin means D plus is connected to the other fuse resistor, and the 4th pin is connected to the ground. Always the 4th pin is connected to the ground, as you can see. So let's check in the other motherboards. Okay, so you should always check the chemical capacitor. Check also this inductor if you have one inductor that is failed. If the inductor is failed, you will not hear a buzzer. You will not get a continuity. The inductor is exactly like a fuse. You should get a continuity when testing it. And for chemical capacitor, you can test it, as you can see, by selecting the buzzer option in the multimeter. Okay, and then let's check the continuity. The continuity is set correctly. So you can check the chemical capacitor by checking its terminals, as you can see. No buzzer, no continuity means this capacitor is good.